Hey everyone, my name is Greg Sager, and today I'm going to show you how to plan a little VFR Nav Log. So this flight, we're going to be going from Columbia County up to Glens Falls. So our nav log ready here. And the very first thing I like to do is grab a blank piece of paper, and we're going to get the weather. So I like to set up my paper in the following way. Where we're departing from, 1 Bravo 1, with the field elevation, so 198 feet, en route, and then our destination, Kilo Golf Foxtrot Lima. And the field elevation for there, as you can see, is 328 feet. Now we don't know what altitude we're going at for our en route yet, and that's because we haven't figured out whether we're going magnetic east or magnetic west, or more specifically 0 to 179 or 180 to 359. So we have to figure that out. So we can actually use the VOR right here, and you can see this part right here, that's true north, or my mistake, that's magnetic north. So you can see that this is going to be magnetic east. So this course line, this course we're going to fly at an odd 1,000 plus 500. So looking at the max elevation figures here, we have 2,600, 2,000, and 3,200. Now that 3,200 doesn't come in until way up here. So I'm going to elect to fly this at 3,500. Now, based on the winds, you could choose different. Today, as you'll see, we have a headwind from the north, so I'd like to stay as low as possible. So we're going to go 3,500. Now, like I said before, this altitude is determined on the magnetic course of your line. So for now, let's go through and get the weather. So I'm going to use Pittsfield's weather for 1 Bravo 1 because it's pretty close. So the winds are 290 at 10 statute miles, sky clear, temperature is -3, altimeter, dew point's -8, and the altimeter 29.901. Great. Now let's look at the winds aloft. So we're looking at Albany here, between 3,000 and 6,000. Okay. So at Albany, 3,000, 010 at 29. And then at 6,000, 350 at 17. And then the temperature at 6,000 is 0. Okay, so that's good for now. And the next thing we'll do is get the weather at Glens Falls. Okay, so the weather at Glens Falls, winds are 080 at 7, overcast 2,000, 10 statute miles, temperature is -4, dew point's -9, altimeter is 3003. Cool. Okay, so I had to change pages for a second. So we have all the weather written down. So what we have to do is let's figure out the pressure altitude here for 1 Bravo 1. So standard altimeter settings 2992. So we need to figure out the difference between 2992, 2991. So we can see that's only 0.01. So that's in the tens place, that's only going to be 10 feet off. Now because it's lower pressure, it's worse for performance, so we're going to add that to our field elevation. So our field elevation is actually going to be at 208 feet. Not our field elevation, sorry, pressure altitude, 208 feet. Now let's interpolate to find the winds and the temperature at 3,500 feet. So if I set this up in a fraction as a percentage, the difference between 3,000 and 6,000 is 3,000 feet. Now how far are we from 3,000? 500 feet. So 500 over 3,000, 16%. So now we're going to want to find the difference in the direction and velocity and take 16% of it. So the difference between 010 and 350 is going to be 20 degrees. So 20 times 0.16 is going to give us 20 times 0.16 is 3.33. Okay. So we are going to subtract 3.33 degrees from 010. So therefore, at 3,500, our wind direction, let's call it 006. So now we need to find the difference in the velocity. Difference between 29 and 17 is 12. So we have 12 times 0.16. And that is going to give us 1.92. So now we're going to subtract 1.92 from 29, so we'll call it 27. Okay. Now we also need our temperature. So we can see, sorry I had to cut it, looking at the temperature. Temperature is 0 degrees at 6,000, negative 3 degrees at 198 feet above sea level. So that's about half a degree increase per 1,000 feet. So we go to 1,000 feet, now we're going to be at negative 2.5. 2,000 feet, negative 2. 3,000 feet, negative 1.5. So we'll call it negative 2 degrees Celsius. Then last, we have to figure out the pressure altitude for Glens Falls. Now how I like to do it in my head, I know to go from 30.00 to 29.92, it's 0.08. I mean, you can do all your math here, 2, 10, 9, 10, 9, 10, 8, there you go. So this is in the tens place, so it's going to be 80 feet. Now to go from 3000 to 3003, we can see that's just 3, which is in the tens again, so it's 30. So it's going to be 80 plus 30, which is 110. Now because this is lower or higher pressure than standard, it's going to increase our performance. So we're going to subtract that. And we're going to get a pressure altitude of 328 minus 110, 218. Now you don't have to do all these steps here. You can just do 3003 minus 2992, and I'll give you the same thing. Give you 110. So now that we got all our weather set, let's come over to our nav log. So I just like to start, note, N number 5404 Bravo. Where are we departing from? 1 Bravo 1. I know our first leg we're going to be climbing, and I know after that we're going up to 3,500. Other than that, that's pretty much all I know right now. So the next thing we can do is let's measure out our true course. So if you get your plotter, line it up from the center of the airport to the center of the airport. Draw a straight line with your pen or your pencil. In this case, I've already done it. And now what we can do is we can use our plotter to figure out the true course. Now there's a couple ways to do this. One, we can put our plotter like this, and if we line the center grommet here on our course line, and then line the ruler up with our course line, on a lat long line. So here I'm using a line of latitude. Now we can see, if we read over here, that, okay, this one's telling me we're going 094 on this outer scale. This inner scale is telling me we're going 274. Neither one of those sound right because we're clearly going north. Now this outer scale down here is telling me we're going 004. That sounds like the right one. So don't get confused with these plotters because there's 4 different sets of numbers. So really think about it, it makes sense. If you're going this way, it should be between 0 and 090. If you're going this way, it should be between 090 and 180. This way, 180, 270, that way, 270 and 360. So make sure it makes sense. Now another way you can use this plotter is if you line up the grommet with your course line, then square up the ruler on that line of latitude there. Now just read up. So yes, the ruler is saying this is 90 or 270 or 0 and then counting backwards. Use it as a protractor. You know that this is 0, you know that this is 10 degrees more, 10 degrees, so on. So if I use this as a protractor, this is 0, 0, 1, 0. So we can again see it's 0, 0, 4. So there's a couple ways to use this plotter. So we're going to put that in for our true course, 0, 0, 4. Now we also need to figure out what our variation is going to be. And it looks like the closest variation line is right here at 14 degrees west. So because it's west, we're going to add it. So plus 1, 4. And that's also going to be our course route, or our magnetic course. So 004 plus 14 is going to give us 018. And now, because we're playing this direct, we're not making any turns along this route line, course line. It's going to stay the same the entire route. Okay. So that's all set there. So the next thing we can do is let's go ahead and pick out some good checkpoints and measure them. So for the first checkpoint, I like to come to the operating handbook because our airspeed for this first leg is going to be what we climb at, and we typically climb at 67 knots. Now once we level off, now we're going to go up to about 100 knots. So if you don't pick a top of climb checkpoint, then let's say it takes you 6 miles to level off at 3,500 feet. Well, you pick your first checkpoint 20 miles away. Now that extra 14 miles isn't going to be at 67, it's actually going to be at 100. So your times are going to be off. So like I said, come to our performance charts here. Time, fuel, distance to climb. So let's see, going up to 3,500 feet, looks like the distance is going to be about 6 miles. Now we know, based on the wind, that we're going to have a pretty strong headwind. So I'm going to go ahead and reduce that. And I'm going to say, make an educated guess, it's going to be about 4 miles. So I'm going to pick our first checkpoint about 4 miles away. So if we grab the plotter, looks like it's going to be right about here on this road. And we can also verify that with these little islands over here. So when we're abeam those islands and crossing this road, we should be hitting our top climb. So I'll put that down for our distance, 4 miles. Now what we're going to call that checkpoint is crossroad and islands to the left. And make sure you make your checkpoints big so you can see them, so you're not really looking too hard for them in the airplane. And you also don't want to pick one point. You want to pick a checkpoint that's got multiple options. So we can see this road where we're crossing it, we have these islands here, we have the town of Coxsackie, and we also have the town of Chatham. So there's a lot of ways for us to identify that, okay, we're at our point. So now let's pick the next checkpoint. So from here, let's use this major highway. You want to pick points that are about 10 to 15 miles apart. So that highway looks a little bit close. It's looking, we'll pick a longer checkpoint. So right here where this road arcs out, we're going to put it there. So we're going from 10, so it looks like 12 miles. 12 miles. Now the way I'm doing that is I see this highway. You'll be able to see it while you're flying. And then you can see where it arcs out here. We're going to want to be just to the left of it, maybe even a little bit over top of it. And it's also right at the start of East Greenbush, so we should be able to see that. Also, it's right at the tip of the base of this pond. So, got a couple good things to center us on this course. Now if we go for the next checkpoint, alright, let's see, 10, we're looking up here about 20. So let's use this bridge here. There's a bridge, Troy Manans. So we're going to use that. And we said that distance was, looks like it's about 10 miles. So 10 miles. And also, don't forget to fill out what checkpoints you're using. So this was, I'll call it arc in highway. Then the next one was a bridge off our left. So good. So now we'll measure up to another checkpoint. And I'm going to make this one a little bit further. I'm going to go for 14 miles here. And I'm going to use this point because we're going to be able to see where we cross this river. And there's also these two towns here. But then the river is going to kink back out. So we want to be just to the left of that kink, and then right over this roadway here. We set the distance for that, just to double check, 14 miles. Okay. So we'll go 14, we'll call it kink and river. Good, so now let's find another checkpoint. Getting close. Now I usually advise against using small airports because they're pretty hard to see, but we're not really left with too many good checkpoints in here. So I was thinking about using this one, but now that I see there's a roadway here and this little split in the river, I'm going to use the split in the river. So right here, put checkpoint. It's a distance of 8 miles. I'm going to say Y in river. Then from that Y in the river, I'm going to go straight to the airport, which is a distance of 19 miles. Or sorry, not 19. 14 miles. 14. And that's going to be Kilo, Golf, Foxtrot, Lima. Okay. So now we got our checkpoints drawn. Our distance is measured the whole way. So we'll set the map aside for now. Course route's going to stay the same the entire way. 018, 018, 018, 018. You're going to find that there's a lot of repetitiveness in this. Also, this is an expired map, so make sure you're doing this on current maps. But the Glens Falls VOR here is out of service. So is the Albany VOR. So we're not going to be using any VORs. So in this box, we're going to leave it blank because we're not using any. Now this process would be the same if you were using a VOR, except your line would go to a VOR and then to your airport. So you'd have two different course routes. Now altitude is going to be 3,500 the rest of the way. Now I know some people will put an arrow going down here to indicate top of descent, but I'd rather have my students stay at 3,500 feet than start to descend if they don't see the airport. So I've kind of folded my map here for the video's sake. You can see there's a lake up here. So if you hit this lake and you haven't seen your airport, you've gone too far. So I'd rather you stay up at 3,500 because you're going to have a better chance of finding this airport. Once you see the airport, then you can kind of plan your descent. Also, now let's put in our winds. So our winds, I've previously used for the climb, the winds at the departure airport. I found that to be pretty inaccurate, so now I just use the winds aloft. So for the wind direction, I'm going to go 0, 0, 6, 27, temperature -2. And I'm going to keep that the whole way, because it really doesn't change much between Glens Falls. The winds aloft we got from Albany, which is right in the middle. It's not -27, -2. Good. So now it brings us to our airspeeds. So if we come back to the performance chart, we can see airspeed calibration. So indicated, calibrated, flaps up. That's how we climb this, with our flaps up. So VY for our 152 is 67. So that falls in between 60 and 70. Here we see the indicated and the calibrated, 60-60, indicated, calibrated, 70-69. So it's only 1 knot difference. So we're going to say that's negligible. So our indicated airspeed is going to be the same as our calibrated airspeed. So for our climb, I'm going to put 67 for our calibrated airspeed. Now to figure out our true airspeed for the climb, you guessed it, E6B. Now it gives you directions on here. So for true airspeed and density altitude, set air temperature over pressure altitude. So we're going to set the air temperature over pressure altitude. Now careful, because positive goes this way for temperature, and also on the pressure altitude, each tick mark is 1,000 feet. So we have departing a pressure altitude of 208 feet and a temperature of -3. So we're going to set -3 over about 208. So you're kind of splitting hairs here. Just get it pretty accurate, best you can. So that looks pretty good to me. We have -3 is right about in here, and we have -200 is right about here. Sorry, -3, it's on this side. So now what we do is we read true airspeed over calibrated. So let's find 67. So here's 65, 66, 67. Read up, and we see 65. So our calibrated airspeed, or our true airspeed, pardon, is going to be 65 for the climb. Good. Now after we do that, we can figure out what our true airspeed is going to be en route. So if we flip to the cruise performance section, we can do a little bit of interpolation on this table here. So we're going at 3,500 feet, so we're going to be in between 2,000 and 4,000, and our temperature aloft, we said, was -2. So that's going to be about in between standard, definitely more closer towards the 20 degrees below standard, and in between 2,000 and 4,000. So if we kind of look at these graphs here, we can figure out what's our true airspeed is going to be. So we want to pick an RPM setting that's going to give us between 65 and 75% brake horsepower. So at 4,000 feet and 20 below, 2,300 is going to give us 70. 2,000 feet, 2,300 is going to give us 73. Standard 69. Standard 66. So it looks like 2,300 is a good RPM setting for us. Now let's compare the airspeeds. 97, 97, 97, and 97. So safe to say our true airspeed is going to be 97. But cruise speeds are shown for an airplane equipped with speed fairings, which increases speeds by 2 knots. So we don't have speed fairings, so we need to decrease 97 by 2 knots for a true airspeed of 95. And that's going to be true for the rest of this flight. Good. Now while we're on this, we should also figure out what our fuel burn is going to be. So if you notice the trend, as the temperature gets colder, so let's look at this column here, 5.4, 5.7, 6.0. So as it gets colder, we're going to burn more fuel. So we know we're not quite this cold, and we're not quite this high. And you can also see that the fuel burn is going to decrease with altitude. So 23 is at 6, 23 is at 5.8, 23 is at 5.5. So if we kind of take the higher value for a factor of safety, let's go with 6 gallons per hour. I'd rather plan to use more fuel than actual. That way I'm still landing with a little bit extra than I planned for. So 6 gallons per hour burning. Now the next thing we need to do is figure out our wind correction. Alright, sorry for that. So like I was saying, we have to get back to our E6B and our whiz wheel to figure out our wind correction angle. So it gives you directions. Place wind direction under true index. So our wind direction we said was, no, we got it written right here, 006 at 27. So we're going to set this up to 006, which is right there, 006. Slide this down to 100. That way it's easy to mark up 27 knots. And now we're going to mark up the wind velocity at 27 here. So drop a little tick at 27. Good. Now after you do that, we're going to place true course under true index. Our true course is 004. So we're hardly even moving it. And now we want to slide our wind velocity mark to our true airspeed line. So for the first one, it's going to be 65. So we're going to slide this all the way down to 65. Almost off the page. And it looks like our wind correction angle is going to be about +1 degree. And our ground speed looks to be about 39. I don't know if you guys can see it. You can pause it if you need to, but it looks to be about 39. So here, for ground speed, 39. Estimated. So now we need to change our true airspeed to 95. So let's slide this up to 95. And we can see that we have, again, about +1 for wind correction, and our ground speed's now at 69. So we'll write 69. Now we're done with this. So we'll go through and fill this all out. So 004 plus 1 gives us 005. Plus 14 is going to give us 019. And we'll just repeat this so our nav log looks complete. Be careful doing this. It's very easy to make a mistake if you're going quick and not really paying attention. Alright. So now the next thing we need to do, deviation. Each airplane is going to have a different amount of deviation based on the compass. And now that results from magnetic fields inside the airplane affecting our compass. So refer to your individual compass card for the specific deviation for your airplane. It's usually fairly negligible, but important to note. So in this case, I'm just going to say our course heading is going to be 019 the whole entire way. There we go. And then 69 is also going to be our ground speed. Now one thing I forgot to note when our climb is how much fuel we're going to use in the climb, pardon me. So let's read the notes. Add 0.8 of a gallon for engine start, taxi, and takeoff. So let's add 0.8 right off the bat here. Plus 0.8 for start, taxi, takeoff. This is based on our mixture leaned. Increase time, fuel, and distances by 10% for each 10 degrees above standard. So we're not above standard. So we're just going to take these values. So to climb up to 3,000, between 3,000 and 4,000 here, we're looking at using about 0.7, 0.9 gallons of fuel. So on the factor of safety, we'll call it 0.9 and round it up. Okay. So now we can use a calculator. You can also use your E6B to figure out the times. I prefer a calculator. And now the way I always tell people to remember this is miles per hour. What's that a unit of? Speed. So distance over time equals speed. So what do we have here? We have distance and we have speed. We're looking for time. So if we need time, multiply it over, divide by speed, you get distance over speed equals time. But now that's going to be in tenths of an hour. So you need to multiply that, or sorry, you need to divide that by 60. So distance, or no, I was right, you got to multiply it by 60. So for the first one, we have 4 divided by 39. 4 divided by 39, that gives us 0.102. So times that by 60, 6.1 minutes. 12 divided by 69 times 60, about 10.5 minutes. 10 divided by 69 times 60, call it 9 minutes. 14 divided by 69 times 60, 12.2 minutes. 8 divided by 69 times 60, 7 minutes. And finally, 14 divided by 69 times 60. Wait. 14 divided by 69 times 60, 12 minutes. So now we can add up the total times. So we got 6.1 plus 10.5 plus 9 plus 12.2 plus 7 plus 12. It's looking like about 56.8 minutes. 56.8. Now we can figure out the fuel. So for fuel, we know that we're burning 6 gallons per hour. So if we take this 10.5 minutes, divide it by 60 to get it back into tenths of an hour. So 10.5 divided by 60. 10.5 divided by 60. 0.175. So now we multiply that by 6 gallons per hour. And it's saying we're going to use 1 gallon of fuel. So now let's do that with the rest of them. So 9 divided by 60 times 6, and that gives us 0.9. Then if we do 12.2 divided by 60 times 6, control answer, so it's going to be about 1.2. 7 divided by 60 times 6, 0.7. And then 12 divided by 60 times 6, 1.2. 1.2. Plus that 0.8 down there. So now we can add up our total fuel. So we got 1.9 plus 0.9. I just add these two together. Plus 1.9, adding these two, plus 2, gives us 6.7 gallons for this trip. So let's think if that makes sense. So we're flying just under an hour. We're burning 6 gallons an hour, not including the full throttle that we're going to be for our climb and also for our start taxi. So 6.7, that makes pretty good sense. Now what I also like to do is I like to come to ForeFlight. I'll just check my work. Let's see how we did. So we'll go flight plan, 1 Bravo 1 Glens Falls. This is for a different 152, but same RPM, same performance. 3,500. Nav log. Looks like our heading is 014 is going to be our heading. So we got 019, so that's pretty close. We're going to use 5 gallons of fuel, it's saying. So we overestimated on our fuel, but like I said, kind of anticipated that. It's going to happen. I'd rather be overestimate our fuel than underestimate it. And it's saying 47 minutes. So our time's a little bit off. This is also in a perfect world computer. So I'm betting we're probably going to be closer to this 56 minutes. So yeah, I like to double check with ForeFlight. Looks pretty good. So what I forgot to show you, which is why I'm going back and adding this into the video, is how to do your time and fuel calculations using an E6B, which this is more realistic because if you're in an airplane and you have to do a diversion, this is going to be better to use this versus using a calculator in the aircraft. So what you're going to do is it gives you directions. So it says for time and distance, you're going to put the arrow right here on your speed, ground speed that is, and then you're going to read down from the distance to find your time. So for this first one, let's look. We have 4 miles at 39 knots. So if we set this marker to 39, which it is, we can then find 4, or in this case 40, and read down from it, which is looking like 6.1. So for this one, it's going to be 6.1 minutes. Then for the second one, we have 12 and 69. So now we're going to adjust our speed to 69. So we're going to go up here, 69. Get as close as you can. Then we're going to find 12. So here's 12. We're going to read down from that. And that looks like 10.4 minutes. Then we have 10 at 69 again, so we're not even going to move our pointer. Now we're just going to go find 10 on here. So 10's right here. So if we read down from it, we see that we have 8.5, 0.6, about 8.7 minutes. Then 14. So 14, read down from it, looks like 12.2. Then 8, so we find 8, read down from it, looks like about 6.9. Then 14, and again, looks like it's about 12.2. So that's how we find our times. So now that we have our times, we can find our fuel looking at the E6B as well. So again, it gives us directions. So for fuel consumption, we're going to set the arrow to our gallons per hour. Then we're going to read up from our time to find the fuel burned. So for now, let's set it to 6 gallons per hour. Good. Also, this first one is not going to come from the E6B. It's going to come from our performance chart because it's based on our climb. So for this first time, 10.4 minutes, we're going to find 10.4 on the inner scale. So 10.4, we're going to read up, and it says 10.4. Now, in 10.4 minutes, we're going to burn 10.4 gallons. Does that make sense if we're burning 6 gallons per hour? No. So what we need to do is we need to move the decimal. So instead of it being 10.4 gallons, it's going to be 1.4 gallons. Sorry, 1.04 gallons. Move the decimal. So now we have to find 8.7 minutes. So 8.7, read up, 8.7. So it's going to be 0.87. 12.2, find it, read up, it's going to be 12.2. So that's actually going to be as 1.22. Then we have 6.9. So we're going to find 6.9, read up, it's 6.9. So it's going to be 0.69. And then 12.2 is going to be the same, 1.22. And then from there, what else we would do is we'd fill out all the information we can about the airports. For example, 1 Bravo 1, field elevation is 198, ATIS here is 13352, there's no ground, there's no tower, departure is 132.82, CTAF's 123.05, 122.2, 12305. Then you could go through for Glens Falls. And you could look all this information up in the airport facility diagram or airport facility directory, also known as the chart supplements now. And you could fill all this in. The other thing I like to do is I'll make a note of some alternate airports. So we can see we have Rensselaer, we have Bennington, we have Albany. So I might make a note up here of certain alternate airports we could go to. Maybe draw a picture of the runways. So like Albany has runway 0119 and 1028. Look up the distances and write them down. Albany's longest runway is 8,500 feet, which is this one. And I also like to write down what runways Glens Falls has. So you look it up. Glens Falls has runways 0119, and they have a runway that goes like this. I'm not sure off the top of my head. You could look it up. That way you can kind of see as you're approaching the airport what runways you're going to be looking at. Also print out a taxi diagram for your own situational awareness as you're approaching the airport. And then the one other thing I like to do as a final check is just go through this acronym. NW Craft, Required Pre-Flight Prep. So N, NOTAMs, TFRs. Weather. Known ATC delays. Runway lengths of intended use. Alternates. Fuel requirements. Takeoff. Landing performance. Okay, so NOTAMs, TFRs, weather, known ATC delays. That can pretty much all be gotten through a thorough weather briefing. Now that means get the weather on your own, do your own research, and then call the flight briefer just to double check that what you found was correct. Runway lengths we can look up and write down on our sectional chart here, just like I showed you I did with Albany. You have to do the same with Glens Falls. Make sure that the length of the runway is sufficient for your aircraft. Alternates, note some alternates along your route of flight. If you're flying up to Glens Falls and let's say you get to about here, Albany, and the weather starts breaking down, where can you go? Well, if you make it this far, I'd probably come back to Columbia County, or you could go here to South Albany. So make note of your alternates. Fuel requirements. This is a day VFR flight. We're using, let's call it 7, round it up, 7 gallons of fuel out of 24.5 usable. Yeah, we're gonna have more than enough to meet our fly to our destination then 30 minutes after reserve. And then takeoff landing performance. This kind of includes a few other things. Do a weight and balance. Now the reason I say do a weight and balance is because let's say you just flip open here your performance charts and you find your landing distances. Now these are assuming you're within your CG limitations. So if you're not even within your CG limitations, this doesn't even apply to you. So do a weight and balance first. Make sure that checks out. Then take off landing distance. So the big part of this video was to show you how to go through and complete the nav log, because I know that's what most people get stumped on. Between picking checkpoints, figuring out true airspeeds, wind corrections, course routes, all that stuff. So that was the main goal of this. A lot of this other stuff you should be able to do on your own. If you are unsure of it, just let me know. I'll answer any questions you have. But other than that, that's pretty much all I got for you. Thanks.